Good afternoon. So for today, we're going to talk about the integration by substitution. This is a lecture part all about integrals. So this is the part 2 of our basic integration lecture. So integration by substitution basically is just the simple technique that employs the use of derivatives. So we're going to recall our basic derivatives here. So let's start. So we have here 10 equation or 10 samples, 10 examples. So we shall be computing all the integrals of this example. So let's start by number 1. So the integral of x plus 1 raised to 10 dx. So for number 1, that should be the integral of x plus 1 raised to 10 dx. Okay, so by the name itself, integration by substitution, we shall be substituting some values for the integrand. So for that, we must let u equal to the integrand, that is x plus 1. Okay, and if we get the derivative of this u with respect to x, du over dx, we should be getting an answer of 1 because the derivative of constant is 0. So if we cross multiply this, du is equals to simply dx. So integration by substitution, we can simply rewrite this integral as this. The integral of the u, that is the x plus 1, raised to 10. But when we get the derivative of u with respect to x, it turns out that du is only equal with dx. So we can replace dx simply by du. Okay, so and now if we get the integral of this is simply power or integral of power. So u raised to 11 over 11 plus c, or when we back substitute the value of u is equals to x plus 1 raised to 11 over 11 plus c. That's the integral of our first example. Okay, how about for the second example? So for the second example, we have the integral of x squared plus 1 squared 2x dx. Same process, we must let the integrand equal to u, which is x squared plus 1. And when we get the derivative of u with respect to x, we will be having 2x. And when we cross multiply dx with this, du is equals to 2x dx. From our integral, we can see here that 2x dx is already given. So we can simply replace this part as du. Okay? Because du is equals to 2x dx. So, and rewriting the integral, we must write this as integral of u, that is x squared plus 1, it's raised to 2 du. Because 2x dx simply is equals to du. Okay? So, we have here the integral of power. So, u cubed divided by 3 plus c. And when we back substitute the value of u, that should be equal to x squared plus 1 raised to 3 divided by 3 plus c. This should be our answer. Pretty much it's easy, right? So we're going just to recall the basic differentiation. Okay? So for number 3, that is the integral of 3x squared times x cubed, or the square root of x cubed plus 1. So for number 3, we have the integral of 3x squared times the square root of x cubed plus 1 dx. Okay, so here we can see that if we let u is equals to x cubed plus 1, when we get du over dx of u, that should be 3x squared. And that is basically given by this 3x squared times dx. So we can simply rewrite this as the integral of x cubed plus 1 raised to 1 half times the 3x squared dx. So here, if we cross multiply du over dx with 3x squared, so we shall get 3x squared dx. So simply, here is our 3x squared dx. We can simply substitute this as du. And again, x cubed plus 1 as u. So u raised to 1/2 times du. Okay? So u raised to 1/2, that should be u raised to 3/2 because 1/2 plus 1 is 3/2 over 3/2 plus c. So in other words, simplifying, 2/3 of u raised to 3/2 plus c. Now, back substituting our value for u, which is actually equal to x cubed plus 1, we shall get the value 2/3 of x cubed plus 1 raised to 3/2 plus c. And this is now the final answer for our integral. Pretty much easy, right? So, okay. So let's proceed with number 4. Number 4. Okay. So number 4 is actually, what is the integral of x times x squared plus 1 squared dx? Okay. So, we must again let u equal to x squared plus 1. When we get the derivative of u with respect to x, that should be 2x. Cross multiplying, we have du is equal to 2x dx. Okay, we have a dilemma here because if we're going to rewrite this integral in such a way that x squared plus 1 will be coming first, squared, that is multiplied by x dx. We can see here that we have an x dx here, but what we get for du is 2x dx. So we don't have 2. Okay, in order for us to substitute this x dx simply by du. So what are we going to do is that we're going to have an integral here, x squared plus 1 squared, and then we're going to add 2 here so that it fits our du. But if you add 2 here, outside of the integral symbol, we must multiply it also by 1/2 to compensate for what we have added here inside. Okay? So, if this is now the given integral, okay? If this is now the given integral, we can directly substitute this as, still, we have the 1/2 integral of, this is u squared, 2x dx is simply du, so that if you evaluate that, 1/2 raised to times u cubed over 3 plus c, or simply we have 1 over 6 u cubed. Our u raised to 3 is actually equal to x squared plus 1 raised to 3 plus c. So this is our final answer. Okay? So, okay, let's proceed. For other examples, for number 5, we shall be answering x squared times the square root, okay, of x cubed plus 1. So number 5, we have find the integral of the x squared, multiply it by x cubed plus 1 dx. So, again, letting u is equals to x cubed plus 1 du. Okay, I will try to simplify it. So, du over dx is 3x squared dx. Okay, I cross multiplied already, so just to save some space, 3x squared dx. But here is our problem again. We're going to rewrite our integral such that x cubed plus 1 raised to 1/2 comes first. We have x squared dx here. So the same problem as we have encountered from the previous example, we have x squared dx here. Now we have 3x squared dx here. So what are we going to do is that we have the integral of x cubed plus 1 raised to 1 half. Then we're going to add 3 here such that it fits our du. But remember also that when we add here 3 here, we must also add 1/3 here just to compensate for it's always the reciprocal of what we have added here. Okay? So to compensate for the 3 that we add here. So what will happen is that 1/3 will now be the integral of u that is equivalent to x cubed plus 1 raised to 1 half times du. So again, we have 1/3. By power formula, we have u raised to 3 halves over u raised to 3 halves, or u raised to 3 halves over 3 halves plus c. And if you're going to simplify that, that would be 1/3 times 2/3, okay, times u raised to 3 halves plus c. So simply, we have 2 over 9. U is equals to x cubed plus 1 raised to 3 halves plus c. So this should be our final answer. Okay? So for number 6, okay, we shall be doing this. For number 6, we have the integral of, let's say, x times x squared plus 1, let's say, raised to 10 dx. Let's just modify our example. Okay? Let's write here raised to 10. Okay. So, what are we going to do is simply the same. Let u is equals to x squared plus 1, while du over dx should be 2x dx. So here we have a problem again. We have to add 2. Okay, so that's the integral of x squared plus 1 raised to 10 times x dx. But we need to add 2 here. So adding 2 here means adding 1 half outside of the integral, or multiplying it by 1 half. So 1 half integral of u raised to 10 dot du, or times du, that should be 1 half u raised to 11 over 11 plus c. Okay? And that is equivalent to 1 over 22 times x squared plus 1 raised to 11 plus c. Well, actually, integration by substitution became handy. Why? Because if we're going to evaluate this x squared plus 1 raised to 10, we shall be using Pascal's triangle, which is, well, time-consuming and very difficult, and expand this whole expression. But using integration by substitution, we can simply get the integral by implementing u and getting the derivative of u with respect to x. Okay, so for our number 7, so we have, for number 7, we have 8x squared. So for number 7, we have the integral of 8x squared over x cubed plus 2 cubed dx. Okay, so what are we going to do is, applying our simple integration techniques, we can simply put 8 outside of the integral because that's a constant, x squared over x squared plus x cubed plus, oops, let me just erase, that is over x cubed plus 2 cubed. Okay, dx. So what are we going to do is, we can simply still use integration by substitution by actually what? Bringing up this expression x cubed plus 2, but with a negative exponent, times the x squared dx. Okay, so if we let u is equals to x cubed plus 2, then du over dx should be 3x squared times dx. So as you can see here, we have an available x squared dx, so we have to multiply this by 3. And again, outside of the integral, we must have an offset of 1/3. So what will happen here is that a times 1/3, that is due to the 3x squared here, that's the integral of x cubed plus 2 raised to negative 3 times 3x squared dx. So we can simplify this expression as 8 over 3 integral of u times raised to negative 3 times du. Okay, so 8 over 3 integral of u raised to negative 3. So what will happen is that that should be u raised to negative 2 over negative 2 plus c. So simplifying 8 over negative or 6, negative 8 over 6, because if we factor out 1, negative 1 up here and multiply it, we shall be having negative 8 over 6 times u raised to negative 2 plus c. But we can simplify this further. This is negative 4/3, and we can bring down our u here such that it's u squared plus c. So in other words, negative 4 over 3 times our u squared. What is our u? That is x cubed plus 2 raised to squared plus c. So this shall be our final answer. Okay, so let's proceed to number 8. So number 8 is x squared over fourth root of x cubed plus 2. So for number 8, we have the integral of the x squared over the fourth root of the x cubed plus 2 dx. Okay, so if you get the integral of that, again, we shall be using our concept. So we have x cubed plus 2 raised to negative 1/4 times the x squared dx. So what will happen is that if we let u is equals to x cubed plus 2, we have du, which is equivalent to 3x squared dx. So we have an x squared dx here. We must multiply this by 3 and offset a 1/3 outside of the integral. So we have now 1/3 of the integral of the x cubed plus 2 raised to negative 1/4 times 3x squared dx. So we can substitute 1/3 the integral of u raised to negative 1/4 du. So we have here 1/3 u raised to negative 1/4 plus 1, that should be 3/4 raised to 3/4 over 3/4 plus c. So simplifying 1/3 times 4 over 3 times u raised to 3/4 plus c. So we have 4 times 1, 4 over 9. U is simply x cubed plus 2 raised to 3/4 plus c. I hope you're getting it. I hope you're following our discussion here. I hope you could follow. Huh? So, very simple. Okay? Okay. Down to our number 9. So, for our number 9, we have, again, what's our given? 3x. Okay? So, for number 9, we have the integral of 3x times the square root of 1 minus 2x squared dx. So we must let u equal to 1 minus 2x squared. So du will now be negative 4x dx. Okay? So for our integral, we can rewrite this as, first, factor out 3 because that's a constant. Okay, so times x times 1 minus 2x squared raised to 1 half dx, or simply we can rewrite this as 3, the integral of 1 minus 2x squared raised to 1 half times x dx. But in our du, we have what? Negative 4x dx. So what are we going to do is that simply 3, okay? So we will be adding negative 4 here. So we must be adding also outside of the integral or multiply it by negative 1 over 4. Integral of 1 minus 2x squared raised to 1 half times negative 4x dx. So we can have here negative 3/4 times the integral of this is equal to u raised to 1 half because this integrand is equal to u. We let that as equal to u. Negative 4x dx is simply equal to du. So we can now evaluate the integral of that. So that should be u raised to 3 halves over 3 halves plus c, or simplifying, we have 3/4 over 2 over 3 times du, that is 1 minus 2x squared raised to 3 halves plus c. Simplifying, here we can see the 3's will cancel. 2 over 4 is simply 1 half times 1 minus 2x squared raised to 3 halves plus c. Okay. So down to our last number, we'll be having this example. So the integral of a squared minus y squared raised to 5. The integral of a squared minus y squared raised to 5 dy. So here we can see here that if we let u is equals to a squared minus y squared, if we get the derivative of u with respect to y, again because we have the dy here, so that is equivalent. This is a constant, a squared. So simply the derivative of constant is 0. So we have here negative 2y, or du is equals to negative 2y dy. So again, we don't have any or wait. So my mistake, we should have y here, okay, according to our given. Okay, we should have y here. Okay, going back, we will be having this again, the integral of a squared minus y squared raised to 5 y dy. So as we can see here, we can replace this as, so our du is negative 2y dy, so we have to add or to multiply this by negative 2. So we have to offset it by adding also negative 1 half outside of the integral. So we have now a squared minus y squared raised to 5. That is now times 2y dy. So again, negative 1 half integral of, we can replace this as simply as u raised to 5. Negative 2y dy simply du or dy. Okay? Or du, I mean. Du. Not dy, but du. Okay? So, again, power formula, negative 1 half u raised to 6 over 6 plus c. So, simplifying, negative 1 half times 1, 6. That is negative 1 over 12. Our u raised to 6 plus c. So, simply negative 1 over 12. Our u is a squared minus y squared raised to 6 plus c. And that should be our final answer. And I do hope, guys, that you learned something today. And thank you so much for listening. This is integration by substitution. And this is Engineer Abat. See you again on the next video.